Hello, this is Mr. King, and welcome back. We're going to begin Chapter 8, Exploring Polynomials. Today's lesson, 8-1, Multiplying and Dividing Monomials. We have a few terms we want to review to make sure that we are ready to proceed. First term is exponent, remembering that exponent is the power to which a quantity is raised. Okay? This is an exponent, 7 to the third power, 7 to the fourth power. It's the power to which a number is raised. And our second term is monomial. That's an expression with only one term. This 7 is a monomial. There's only one term there. And we'll see other monomials as we move forward. We're going to focus again on multiplying and dividing. Let's look at multiplication. We're going to use an example. We're going to say 7 to the third power times 7 to the fourth power. We actually have two ways that we could solve this multiplication problem. We could take 7 to the third power and multiply 7 times 7 times 7 and get the answer of 343. And then take 7 to the fourth power, which would be 7 times 7 times 7 times 7, which would be 2401. Take 2401, multiply it times 343, and get a total answer of 823,554. What we want to do, though, is find an easier way, a shorter way of getting to this. So we are going to take 7 to the third power and multiply it times 7 to the fourth power. And this time, what we do is, when we have like bases, we can add our exponents. So 7 to the seventh power is the same answer that we got before, 823,543. So we want to make sure we focus on our rule here. And our rule is, when you multiply like bases, the bases being the sevens, the numbers that are being raised to a power. When you multiply like bases with exponents, add the exponents and solve. So we added 3 plus 4 is 7. And then we have 7 to the seventh power, and we get 823,543. Okay? Note, you must have like bases in order to add the exponents. Let's take a look at one more problem in multiplication. We're going to take a monomial, 3x to the third power, and multiply it times 5x squared y to the second. Okay? We're going to take our terms, the numerical terms, 3 times 5, which we can multiply and get 15. We can take the x and multiply it 3 times here. We can take the x squared and multiply it 2 more times. We can write down our answer of y to the second power. And if we add this up, we have 1, 2, 3, 4, 5, x to the fifth, and we have y to the second. So we end up with 15x to the fifth, y to the second. Now, using the skills we learned just a few minutes ago, let's take the same problem and know that if we have like bases, this x would be like to and similar to this x here. What did we say we do? We add exponents if we have like bases. So we have an x to the third and an x to the second. X to the third and x to the second give me x to the fifth. We are multiplying our 3 times our 5 and get 15. We put it all together, we get 15x to the fifth, y to the second. Okay? Like bases, add exponents. When we're thinking about division, when you're working on a division problem, once again, we're looking for like bases. So when we are doing a division problems and we have like bases, we subtract the like base exponents. For example, 15 to the ninth power divided by 15 to the sixth power. Well, we have like bases of 15. So we take the 9, subtract 15. We get 15 to the third. That's a lot better than putting 15 in your calculator, raising it to the ninth power, getting a huge answer, dividing that by 15 to the sixth power, which is another huge number, and solving it. Remember, subtraction is used when we're division, but only when we have like bases. Take a look at this monomial here. It's truly one term. 36x to the 10th, y to the 9th, divided by 3x to the 6th, y to the 3rd. Well, we are going to take our numerical part. They're different, so we're going to divide that. And we know 3 goes into 36 12 times. But now we have x to the 10th and x to the 6th. They are like terms, so we can subtract. And we have y to the 9th, y to the 3rd. We can subtract that too, okay? So if we take 10, subtract 6, we get x to the 4th. We get 9, subtract 3, we get x to the 6th, okay? Our final answer becomes 12, x to the 4th, y to the 6th. Remembering that we have like terms, and we are going to divide when we have like terms. One last thing. Let's take a look at a practice problem. We have 4ab divided by 2a, and we have 3x squared y to the 3rd z divided by 4xy. I want you to try this, and
please report to the main office.
Excuse me for the interruption. Let's try it, and I'll look for your answer when I see you in class. Thank you.